Hello everyone, welcome to Urban Subnet. Today we're going to discuss EtherChannel. We're going to explain in detail how EtherChannel works, how it combines the ports together, and then we're going to show you the configuration of an EtherChannel on two switches. What is EtherChannel? EtherChannel is a process of grouping physical switch ports into one logical interface. The logical interface provides load balancing, high-speed links, and fault tolerance. So if you have four 1 gigabyte interfaces and you combine them together in the EtherChannel, you're going to have one logical 4 gigabyte interface. And that will create a higher speed link between your two switches. EtherChannel was developed in 1990 and Cisco Systems purchased the technology in 1994. Cisco developed a port aggregation protocol, which was a proprietary protocol that forms EtherChannel links on Cisco switches. The thing with proprietary protocols is that they only work on the Cisco devices. So if you had a Juniper switch or a Dell switch, you may not be able to get this to work on those other vendors' switches. In 2000, IEEE passed 802.3 AD standard version of EtherChannel. This standard is called Link Aggregation Control Protocol, or LACP for short. This allows switches of different vendors to form EtherChannel ports between them. So you could use a Cisco switch and a Brocade switch and form an EtherChannel between the two of them. How does EtherChannel work? Okay, what it does is it forms it has a load balancing traffic across the links. So that's what EtherChannel does. It load balance traffic across the links of a port channel by reducing a part of the binary address in the layer 2 frame to a number that will send the traffic across a specific link in the port channel. And that may be a little complicated, especially when you're talking about binary addresses, but this is how it determines which link is going to send traffic across. The algorithm is deterministic if the session information of the addresses in the layer 2 frame are the same. So if you have the same destination and source MAC address in the layer 2 frame, the traffic is sent across the same link. This algorithm prevents out of sequence packet delivery. So you want your packets to be delivered in sequence so they can be rebuilt on the other end without any errors or any problems with being able to view or understand the data that's being sent across the link. Link Aggregation Control Protocol, or LACP, is 802.3 AD standard. This allows us to manage EtherChannel between devices that conform to the standard. So, like I said earlier, if your device conforms to this standard, whether it's a Juniper, Brocade, Extreme, Dell brand of switch, they would be able to form an EtherChannel connection. And EtherChannels are dynamically created when devices exchange LACP packets between the Ethernet switch ports. So once the switches start communicating with each other through the switch ports, if the LACP packet gives it the correct information as far as speed, duplex, VLAN, etc., the EtherChannel port can be configured automatically on the switch for you. LACP modes. Now LACP has modes to help negotiate the state of the EtherChannel. So you have the active mode. When the port is in active mode, the port is placed in active negotiation state. Negotiations with the other port begins once LACP packets are sent. So if they're in the active mode, the negotiation starts immediately once the LACP packets are sent. Passive mode places a port into a passive negotiation state in which the port responds to LACP packets that it receives. So it doesn't send, it receives. The port does not start LACP packet negotiation. This setting minimizes the transmissions of LACP packets. So you can put it in passive mode, and to reduce the number of packets going across an interface if you're not going to form an ether channel on the other end, or if you're not sure you're going to form an ether channel on the other end. LACP port negotiations are as follows. Active and passive LACP modes enable ports to negotiate with partner ports to an ether channel based on criteria such as the port speed, and for layer 2 ether channels based on trunk state and VLAN numbers. Ports can form an ether channel when they're in different LACP modes. The modes must be compatible. So a port in the active mode can form an ether channel with another port that is in the active or passive mode. So an active port can form an ether channel with a port that is in the active or passive mode. So that is something that you want to remember. A port in the passive mode cannot form an ether channel with another port that is also in the passive mode because neither port starts a LACP negotiation. So remember, when the port is in passive mode, it will not send any LACP packets. So if it's passive on both ends and you're wondering why your port channel or ether channel is not coming up, that's the reason why they're not sending any LACP packets. In the ether channel configuration, you're going to be able to add up to 8 ports into your ether channel. So you could put 8 switch ports, group them together into your ether channel. So if your ports are 10 gigs and you combine 8 10 gig ports together, you're creating a logical interface that can have speeds up to 80 gigabytes, and that's pretty fast for network speeds. With layer 2 ports, use the channel group interface configuration command to dynamically create the port channel logical interface. So you go into the switch, you go into the interface, you set up your interface, and then you do the channel group command to place the port into the port channel that you're configuring. With layer 3 ports, you should manually create the logical interface by using the interface port channel global configuration command first, then followed by the no switch port interface configuration command. Then you can manually assign an interface to an ether channel by using the channel group interface configuration command. So layer 3 ports use IP addresses, and they can route traffic based on the IP address and the network that that IP address resides in. So in this case, you want to create your port channel interface first, set that up, put your IP address and the other configuration on the port channel interface. Then you would go to your individual switch ports and use the channel group command to add them to the port channel. And we're going to do some videos on setting up and configuring port channels also. So you'll have plenty of references to go to see how this is set up and how it works. The configuration syntax is not complicated for a basic port channel. You're just going to do your config T to enter global configuration mode. Then you're going to go into your interface. In this case, we're using interface FA0/1. And you can also, if you're going to port channel the first 4 interfaces, say 1 through 4, you can do the interface range FA0/1-0/4, and you can configure all 4 ports at the same time. You can do the switch port trunk encapsulation .1Q. Switch port mode trunk allows for multiple VLANs to go across your ether channels, and then the channel group mode active for whatever ether channel you're going to put the port in. So you should put channel group mode 1 active, and then on switch number 2 you're going to do the same thing, config T. Then you go to interface FA0/1. You're going to switch port trunk encapsulation .1Q, and then you're going to switch port mode trunk to allow multiple VLANs across. And you're going to do channel group, the number, channel group 1, mode active, and then the options are passive or active. So in this case, we could have actually put passive on switch 2 and still form a ether channel. But if we put passive on both switch 1 and switch 2, we would not form an ether channel. The port channel 1 interface will be dynamically created, as we mentioned earlier, on the switch now. that you enter these commands. You can enter the port channel interface with the command interface port channel 1. Once you're in the port channel interface, you can run numerous commands on that interface. It's like any other switch port interface. That is a layer 3 interface. Even in the layer 2 interface, you can run various commands. So you type the question mark and it'll give you help to show you what commands you can actually type once you're in the interface mode. And here we're doing a output of the show port channel 1 command. So as you can see, we had configured our switches, and then we do the show interface port channel 1. We see the port channel is up. It has a hardware address which is called our MAC address. The MTU, maximum transmission unit size, is 1500 bytes. The bandwidth is 2 gigs, because remember, we combine two 1 gig interfaces together to create a 2 gig logical interface. And then you have your reliability, transmission load, receive load. Now on the transmission load, you have 1/255, which means there's not a lot of traffic going across. Now sometimes you'll be troubleshooting at work and you see a transmission load or receive load of 255/255, which means your interface is maxed out at the amount of speed that it can transmit packets across. Our interfaces are in auto duplex and auto speed, so they negotiate the speed between them, which we already saw above, which is a bandwidth of 2 gigabytes. And there's other information in the output to show you the how long the interface has been up, what your queues look like, the levels of your queues, and when the interface counters were cleared, and so forth and so on. So we have configured the interface. We see that they're both up, and so now our configuration is done. So I like to do a little pop quiz at the end of the video, just to because if you're studying for your CCNA or any of your certification exams, you're going to get questions on EtherChannel, that's for sure. So here's our first question. What is the IEEE standard for link aggregation control protocol? So in 2000, the IEEE passed the 802.3 AD standard, which is for the LACP protocol. So that's for our EtherChannel protocol. Now with this protocol, remember, multiple vendors can form port channels with each other. Question number 2, can ports form an EtherChannel if they are configured in different LACP modes? The quick answer to that is yes, but the modes must be compatible. So remember, a passive switch port connected to another passive switch port will not form an EtherChannel, but a passive switch port connected to an active port will, and an active port connected to an active port will. Question number 3, what is the maximum number of interfaces that can be added to an EtherChannel port group? Up to 8 ports can be added to an EtherChannel. You can have just 1 port in the EtherChannel if that's all you have available, if that's what you desire, or if your network topology says you're only going to put 1 port in this EtherChannel, and it will still work. There won't be any load balancing there. Of course, you won't have link recovery because you only have 1 link. So if the link goes down, your port channel will go down also. If you have more than 1 port in your port group, say you have 4 ports in your EtherChannel and one of the ports goes down, the traffic will be load balanced across the remaining 3 ports that are up. This is called auto recovery for the EtherChannel port group. So I want to thank you for viewing our video today. I hope this helps you get started on your networking career. I've been in the IT field for over 20 years, and it's been very rewarding. So I want to thank you for viewing. Have a good day.